Hello there. Today we're going to be answering the following question. An experiment consists of randomly drawing a card from a standard deck of 52 cards. Find the probability of drawing A, a 2 or an 8, and part B, a heart or a 3. So in order to do part A, which I will do in blue, we need to look for a clue on which equation to use. So when you're doing probability type questions, you will usually be given a statement that is in terms of either the words or and. Here we're given the word in the question in terms of or. So when you think or, think union. So union meaning you are gonna add up the probabilities, so to speak. Okay. So with this equation, so we're gonna use the equation probability of A union B is equal to the probability of A plus the probability of B, subtract the probability of A and B. So the reason why you gotta do that is because if the events are mutually exclusive, then we're just gonna get rid of the last term. But if the events are not mutually exclusive, then both of them kind of affect the probability of the other. But here, so we're taking one card from the deck, and let's let A equals drawing a 2. Let's say B is drawing an 8. Okay? So here the last term over here, probability of A and B, would be asking what is the probability of drawing a 2 and drawing an 8? Well, here we're only drawing one card. So the probability of drawing both an 2 and an 8 while drawing one card is 0, right? Because that can't happen. So that term is going to go away. So we're just going to be left with probability of A union B is equal to the probability of A plus the probability of B. And all probability type questions can be broken down into a ratio, so to speak. So the probability of an event, E, let's say, is equal to, in general, the number of ways that the event E can occur divided by number of total possible events. So you can think of most probability questions in this way. So if we can figure out the number of ways that the event can occur over the total number of possible events, then we can figure it out. So here, probability of A is equal to the number of the probability of drawing a 2, so that's the number of ways that of the event of drawing a 2 can occur over the total number of possible events. The number of ways that we can draw a 2 from a deck of cards are 4, because we got spades, clubs, hearts, and diamonds. So there are 4 ways to draw a 2. Over a total number of possible events, well, there's 52 cards, so there's 52 different cards that we could pull, so there's 52 possible events. So that would be 52. Similarly, for B, the number of ways of drawing an 8 is 4, because there's 4 8s as well, over 52 ways. So the probability of A union B is just going to be the sum of these two events. Just going to be 4 over 52 plus 4 over 52 is 8 over 52. And we can divide top and bottom by 4 to get 2 over 13. And that will be our answer in terms of our fraction. Okay, so there's that one. Now, going to part B, let's switch colors here. So here. So here, we're going to let A represent drawing a heart. And we'll let B represent drawing a 3. Okay. So I'll check it out. So we're going to use the same formula that was used up here. So let's check out the probability of A first. The probability of drawing a heart. Well, there are 4 suits in a standard deck of 52 cards, and in each suit there are 13 cards, from ace to 3 up to 10, and then jack, queen, king. So there are 13 ways of drawing a heart over 52 total cards in the deck. Probability of drawing a 3, well, is very similar to drawing a 2 or drawing an 8. There are 4 3s in the deck, and there are 52 cards in the deck, so that's how we do that. Now, this one, part of A and B. So drawing 1 card, what is the probability of drawing both a heart or a 3? So, or no, in this case here, so this upside down union sign is the intersection sign, and that represents and. So here we're going to have to subtract the probability of drawing a heart and a 3 at the same time, because if we add up the probability of drawing a heart and the probability of drawing a 3, well, some of that quote-unquote probability is represented in both of them, because that's how it works. So here was the probability of drawing a heart and a 3. Well, there's only 1 card in the deck that represents that scenario, and that would be the 3 of hearts. Because if we have another suit, like a spade, diamond, or club, well, that doesn't do anything for us. And if you have a number other than 3, that doesn't do anything for us. And there's only 1 3 of hearts in there, so there's one way to draw that, or 52. And so in this situation, the probability of A union B is equal to the probability of A plus the probability of B, subtract the probability of A intersection B. And then we put that in there. Probability of drawing a heart is 13 out of 52 plus 4 out of 52, subtract 1 over 52. And this will give us 16 over 52. And we can divide top and bottom by 4 to get 4 over 13. So comparing these two probabilities we have here, so let's compare this one here with this one here. Because they have the same denominator, we can easily compare them. So what this is saying, that the probability of drawing a 2 or an 8 is less likely than drawing a heart or a 3. And that makes sense because there are only 8 different cards in the deck that fit either a 2 or an 8. But there are many more cards in the deck that fit the description of drawing a heart or a 3. So you could have the ace of heart, 2 of heart, up to 10 of heart, and the jack, queen, king of hearts. And the 3s, well, there's the 3 of heart, which was already counted, and then the 3 of clubs, 3 of diamonds, and 3 of spades. So that's why the probability of drawing a heart or a 3 is greater than the probability of drawing a 2 or an 8.